Upgrading electrical service for a new home to support electric vehicle chargers, modern heating and cooling, and high-demand appliances requires planning from day one. Begin by calculating load using the National Electric Code method or a qualified electrician's manual calculation. Accounting for continuous loads like electric vehicle chargers and heat pumps and diversity factors for appliances, then size the service accordingly so you do not undersize the main feeder. For most modern homes, plan for a 200 amp main or larger when you expect concurrent heavy loads, and place the service equipment in an accessible, ventilated location that meets clearance rules and meter placement standards. Add dedicated circuits for high-demand appliances and plan subpanels near additions or detached structures to avoid long branch runs and voltage drop. Use properly sized copper conductors and consider 3% voltage drop limits for sensitive equipment. Install arc fault circuit interrupter protection on all living area branch circuits and ground fault protection where required near water sources and outdoors. These devices protect wiring and occupants and are code required in many areas. Run conduit, or at minimum, install a continuous sleeve from the service location to areas where future circuits might be needed, so you can pull new wiring later without invasive demolition. Coordinate with the local utility early to confirm transformer capacity, meter socket type, and whether service upgrades will require temporary power planning during construction. Keep a permit and inspection schedule as part of the construction timeline, and hire a licensed electrician to prepare plans and sign off on final connections so the work is safe and insurable. Common mistakes include undersizing the main service, which leads to costly retrofits and temporary power limits. So avoid that by planning for peak foreseeable load and choosing a main rated 200 amps or larger. Another issue is neglecting space and conduit for future circuits, which causes expensive wall openings later. Solve this by installing conduits and subpanels during rough framing and keeping spare breaker spaces in the main panel. A third problem is missing required protective devices or incorrect device placement, which can create hazards and failed inspections, so follow code for arc fault and ground fault protection. Document device locations on plans, and have the electrician verify settings and test operations before final inspection. We operate bighomeprojects.com to help homeowners connect with local contractors and find information relevant to service upgrades and other major home projects. We also host a discussion community where we and other members share experiences, recommendations, and practical tips to help contractors find work and homeowners plan upgrades.